DNA does, so it passes on information, right? But the way it does that is by working like an instruction material. So it's telling your body, it's telling your cell what it's going to do once it's supposed to do it. So yeah, we are going to learn more about how this instruction material works. So, has anybody here seen what a DNA looks like? Silently raise your hand if you know what it kind of looks like. All right, Caleb, can you tell me a little bit about how you think it looks like? It looks like a twisted ladder.
A double.
It's a double. I don't even need to teach class today. We're done. All right, let's do that. Come on, man, sit down. I'll show you. So it's a double helix. It's a twisted ladder. Today we're going to learn more about everything that is within that twisted ladder. So yes, as Caleb told us, shape of the DNA is double helix, and it's shaped like a twisted ladder. So here we have our twisted ladder. Okay, these are the base pairs. These are the letters we're going to talk about soon. And these are the sugars and phosphate groups that are what we call the backbone of DNA. So the parts of DNA, now there's still more things for you to be writing on, so I want to see you guys writing down silently with your pencils. Alright, so the DNA double helix has 3 pieces unions that repeat again and again that are called nucleotides. So that's your number 4. Don't forget to keep writing down what you have to write down. So, does anybody here raise your hand silently if you remember what nucleotides are? We talked about it like 5 seconds ago. Yeah, like I mentioned what it was. What? Can you raise your hand? What's up? It's the letters that are part of our DNA, okay? They're the letters in our instruction material. So yeah, this is just, I don't think there's anything for you to write down here. I just want to remind you guys. Nucleotides are the letters we learned on our class on mutation. These are the letters that make up DNA's instruction material. So but the instruction material, instead of being shaped like a book, you know, the little IKEA little guidebook, is shaped like that twisted ladder. And today we're not gonna focus on that, but we're gonna learn about how that happens, like how our body ends up reading that weird shape of a material. Yes, Darius.
What do you mean by twisted ladder?
So do you see how that one? Okay, so you know what a ladder looks like, right? It's like that. But our DNA is shaped like this. So you see how it's kind of like it has steps. So it's kind of like a ladder, but it's not just going straight. It's going this weird mixture. And that's why, for example, remember what I said about 6,000 times if you like put it in a little string? Because it's shaped like that and then it's like bound out really tight, that's how it can fit in your body. Okay? So it's that shape that makes it so you can still have it inside of yourself without it being like exploding in DNA. Okay, so please write this down. There are things for you to be silent writing down right now. Okay, so in a nucleotide, there are 3 parts of a nucleotide. There's a sugar, so you have sugar everywhere in your body, a phosphate group, and a nitrogen base. So this is the sugar, okay? I put it in pink so you guys can like easily refer to that. The phosphate group and the nitrogen base. Please pay attention to the shapes that we have up there. These are what we call conventions. Every time you're going to see these written out in forms, you're going to see the phosphate group being represented as a circle. The sugar is going to be represented as a pentagon, and the nitrogen base is going to be a rectangle every single time. Okay? So if I try to put a question that says that this is a phosphate, you're going to be like, nope. Okay? So the rung of the ladder made of the nitrogen bases. So basically, let me refer back. Is everybody done writing this down? Raise your hand if you're done writing it down. Okay, well we can focus on this for now. But I'm going to refer back to the twisted ladder. So, do you guys remember what the twisted ladder looked like? There's this outside, right? So the twisted ladder had this outside part and these little steps, right? The outside part is made from the phosphate and the sugar. And then the little ladder, the little steps on the ladder, the rungs of the ladder, are made with the nitrogen bases. How are you guys doing? Raise your hand if you are getting this. This is making enough sense. Kind of. Okay, so, Mr. Olo's house. Look at this. All right, Darius, can you hold this down for me, please? Thank you. So this is what the DNA looks like. All right. So these are the phosphate groups and the sugars, and these are the the nitrogen bases, okay? These are what actually contains the information, and this just kind of like holds it together so it makes sense. All right? So can you guys see what's going on here? All right? So this is what your thank you so much, guys. This is what your DNA looks like, and see how tightly it is? That's how it fits in. But if you were to like expand it, like that's what it looks like. All right? Okay. I'm gonna keep going. We can go back to this later. Okay? So remember we were talking about mutations, how there's like letters, words. This is not in your guided notes, but please write down. A is standing for adenosine. Please suddenly write all of those things down. I'm going to explain what all of those things are really soon. Okay, don't worry. So there's A standing for adenine, T standing for thymine, C standing for cytosine, and G standing for guanine. So those are your 4 base pairs. All of this complex things, like all of this complex information that, for example, makes up a Darius, it's written using just those 4 letters. Okay? Those 4 little bases, it writes out, hello Michael Thomas, hello Brianna, hello Tatiana writing down her notes, right? So 4 little letters make everything make sense for you. So that's how amazing it is how your body works. So, maybe this.
Please don't be recording. I don't.
Don't.